This is question 8c. We're told to show that the points P, T and Q are collinear. P and Q are two vertices from the triangle, and these points were given at the start of the question. The point T was the point where both bisectors that we worked out earlier in the question. It was the point of intersection of both bisectors. The question is asking to show that these 3 points are collinear. What that means is that all 3 points lie in a straight line, like so in the diagram. So if the 3 points are in fact in a straight line, then what we can say is the gradient of this part, this dotted line here, must be the same as the gradient of this dotted line here. So if we could work out the gradient connecting the first 2 points, point P and point T, and then if we work out the gradient joining these 2 points, point T and point Q, if both gradients are the same, then that means the 3 points are collinear. Now, it is possible for 2 lines to have the same gradient but not be collinear, like parallel lines. But because point T is common to both lines, then the fact that the gradient here is the same as the gradient here means that all 3 points are collinear. They lie in a straight line. So the first thing we're going to do is work out the gradient of the line and joining the points PT. So if we write down our gradient formula, y2 minus y1 over x2 minus x1. Well, remember we're using points P and T, so y2 is a half. Take away y1, which is 3. And that's divided by x2, which is minus a half. Take away x1, which is 2. So on the top line, we have a half, take away 3. That gives us minus 5 over 2. It's supposed to be a 5 there. Divided by, and then we have minus a half minus 2. And that also gives us minus 5 over 2. So what we have is a negative divided by a negative, which gives us a positive answer. We have the same thing on the top as on the bottom, and anything divided by itself gives us an answer of 1. So the gradient of the line PT is equal to 1. What we want to do now is work out the gradient of TQ. If the gradient of TQ is also equal to 1, then we know the lines are, the points are collinear. So if we write down the gradient formula, but this time for the points T and Q, now this time y2 will be minus 2, and we're subtracting y1, which this time is minus a half. And on the bottom line, it's x2, which is minus 3. And we're subtracting x1, which is also minus a half. So if you had been watching carefully here, you will maybe have noticed that I had made a mistake. We had y2 minus y1 on the top, so y2 was minus 2, and then we were subtracting y1, which should have been just a half. So we'll get rid of this. So it's minus 2 minus a half. The denominator is correct, minus 3, which was x2, take away, and minus a half. So minus 2 minus a half gives us minus 5 over 2 on the top line, and minus 3 minus a half is minus 3 plus a half, which again is minus 5 over 2. So we have minus 5 over 2 divided by minus 5 over 2. So anything divided by itself gives us 1, and the answer is positive. So the gradient m for the line joining points TQ is also equal to 1. Both lines, the lines joining points PT and the line joining points TQ have the same gradient. That means all 3 points lie in a straight line, all 3 points are collinear.